I got 2 months to get you good at problem solving, and I will. So you're going to get better at this. And they will go from really hard to where you'll train your brain to problem solve a little bit more, and they'll get easier, even though the problems are going to get harder. So it's going to be like this inverse relationship. As I train you to do problem solving problems, the problems are going to get easier, but the problems are actually going to get harder. It's kind of crazy. Yeah, it's going to cross somewhere, hopefully. And hopefully that cross through will be the breakthrough point. All right, here we go. Particle moves along the x-axis so that its position t greater than or equal to 0 is given by x of t is equal to 2t x e to the negative t. All right, first question. Here's how you grade a free response question. Say particle moves along the x-axis. They give you the position equation. Out of all the free response questions I have, this is one of the few problems I can find where they actually give you position to start with. Do you notice your free response packet that I gave you this weekend? They didn't give you position. They gave you what? So you actually have to go backwards to find position. And I'm actually, before we leave today, I'm going to give you that. I'm only going to get through this one. And then we'll do the other two tomorrow. So you got x of t is equal to 2t e to the negative t. Okay? I want to find acceleration. Ready? How are we going to find acceleration? Find the first derivative first and then do what? Second derivative. So let me walk you through this and tell you how you're going to gain some points, because this part A is worth 3 points. So we got x prime of t, pay attention, is equal to the derivative of the first function, which would be what? 2 times e to the negative t plus the first function times the derivative of the second, which would be e to the negative t times negative 1. When you simplify that, you're going to get 2e to the negative t minus 2t e to the negative t. Agreed? There's a point. 1 point right now. Go ahead and give it to you if you got that. Now, did anybody factor it? Anybody factor it? That is also okay. You got both of them? So, did you factor out a 2 or not? So you would actually have what?
1 minus t.
1 minus t. And there's a benefit to doing that. And later on, you're going to want to do that. In fact, in part B, we're going to want to do that. So, now I don't care which part you got. Does anybody tell me where you took the derivative from? Did you take the derivative from the factored part or the unfactored? The factored? So we should get to the same answer though. You'll know in a minute. I'm going to do the unfactored because it looks like everybody else did the unfactored version. So it's going to be very similar. 2e to the negative t times a what? Negative 1, right? To get rid of this, we're going to need what again? Product rule. Now here's what I do. I don't take the negative with the 2t because sometimes it gets messy. So I leave the negative out and then I distribute it later. And some of you are like, well, that's extra work. Well, it is, but I just want the negative out of there. So sometimes you get too many negatives in there and it just gets messy. So derivative of 2t is 2 times e to the negative t plus 2t times e to the negative t times the negative 1. Now, when I simplify this, here's what I'm going to end up with. End up with a negative 2 e to the negative t minus a 2e to the negative t again, because now I'm distributing the negative. This already has a negative, and there's a negative, so it'll be plus 2t e to the negative t. So I end up with, for my second derivative, negative 4e to the negative t plus 2t e to the negative t. And you can have the e to the t factored out again. You can even move it to the basement if you want and put it all over e to the t. I had somebody do that. But here, regardless of what you did, there's my second derivative. That is another point. That's a second point. Now, let's say you messed up somewhere along the lines here. Okay, and you didn't get the first derivative, which was this. And you didn't get the second derivative. But you knew what to do. You knew to go down 2 derivatives and find a of 0. You still get this point as long as you use your incorrect second derivative correctly. Now, if we all got the right answer, then here's what we should all get. When we plug it in, negative 4e to the negative 0, which will just be 0, plus 2 times 0 e to the negative 0. This is just going to 0 out. And we're going to end up with this, anything to the 0 power is what? 1, so we're going to end up with negative 4. And if you got negative 4, you pretty much know you had to do the first and second derivative right, or you wouldn't have gotten negative 4.
Is that another point? Or is
That is another point. That's a third point.
No units?
There wasn't any mention of units, so we don't have to have units, and they didn't start doing that until about 2002. Well, what would the units be? Units per second squared, minute squared, hour squared, and then B, the bottom's the part that's squared, so second squared.
Units divided by units.
Yeah. Units divided by unit squared, because we really don't even know what it is.
Yeah.
And we couldn't cancel out units and units squared because we don't know what the units are. Okay? Any questions?
So another point.
Yes, that's 3 points, it should be aware. Now again, if you used your second derivative, if your second derivative is just wrong, but you knew to plug 0 into it, and you plugged 0 into it correctly, and you feel like you got it, then give yourself that point. All right, part B, I think, is really cool. Part B, it says find, you got to know what the question's asking. It says find,
Just
find the velocity of the particle. So here's what you're asking. Read the question, problem solve. What am I trying to find?
find the
I want the velocity
when acceleration equals 0.
when acceleration equals 0. So I need to take the acceleration equation. Watch this.
That equals 0.
I'm going to take acceleration, which is this guy right here, negative 4e to the negative t plus 2t e to the negative t, and I'm going to set it equal to 0. Regardless if you have the right acceleration equation or not, if you knew to set it equal to 0, that is plus 1. If you knew to take a of t and set it equal to 0, that is plus 1. You have it factored out? Well, here's what it looks like factored out. But does everybody got that that has to equal 0? Even if you set a of t equals 0, they don't even need to see the acceleration equation you have. As long as you knew to say, hey, I know that I'm going to have to set acceleration equal to 0 here. That's a point. Pointo, okay?
So if when you were reading the question, you just wrote that inside.
Then you got a point. Because you're demonstrating understanding of what you're being asked. Because some people put v of t equals 0. That's definitely not in the right ballpark. Okay? You're in Dent when you should have been in Chicago.
I'm gonna see you.
Okay?
Wait.
All right.
What if we just were making this and plugged it into the wrong? We plugged it into velocity.
What did you plug into velocity? Oh, because you got t equals. Because find the acceleration when t equals 0. So you took the answer a of t or a of 0 is equal to negative 4, and you plug in negative 4.
That's right.
Yeah, that's not.
Well, actually, did the same thing.
You knew to plug in the velocity for the answer. I can give you 1 point, but you're going to
So
lose
you have negative
2 points.
plus.
And the way this works, guys, I'm going to explain how I grade it tomorrow, because just because you get perfect doesn't mean you don't even have to get perfect, because I'm going to make each free response worth 5, but they're actually graded on the 9-point scale, so it's a rubric. And you can actually have a range to still get that 5 points. So you could actually miss some parts and still get 5 points. That it's worth. I promise. All right, now watch. The way you're going to solve this is you're going to factor out a what?
Either because you're doing 2.
Yeah, whatever, negative 2e to the negative t or 2e to the negative t, I don't really care. You got to get the e to the negative t out of it. There's no choice now. You got to. So we're going to end up with 2 minus t. Now, some of you might have just taken the e to the negative t. The negative 2 really is irrelevant. In fact, right now, what can I do with that negative 2? You could just divide it off and drop it completely. Boom, it's gone. Okay, now, e to the t, we talked about this. Why can this not equal 0? It's an L curve, and if you try and take the L, so just throw that out, so what does t actually equal? 2.
You take 2 plug in velocity.
Now you take that answer and you plug it in the velocity. So now we're going to v of 2. And I'm sure you might have put a decimal answer, but here's what the actual answer is. The velocity is over here. So it'd be 2e to the negative 2 minus 2 times 2 e to the negative 2, which is going to be 2e to the negative 2, ew, negative 4 e to the negative 2, which will be negative 2 e to the negative 2, or negative 2 over e squared. That's the exact answer right there. Now, how many of you gave a decimal? I think it's approximately what? And I'll accept this too. Point. Negative.
0.271.
That's it.
0.271, yeah.
That's also right.
We got a different T.
Which, by the way, if the velocity is negative, which direction is it going at 2 seconds? At 2 seconds, which way is it going? Left. Why? The velocity is negative. Now, if you had a different t value, if you got a different t value, but you knew to plug that t value into velocity, you still get that point.
And then
So
what
we did
we take two.
2 of the 3. Where the difference is yours, you just didn't. You didn't notice that a of t equals 0. But you can still have the point for plugging into velocity.
But then would it be
You can do that part.
would it be traveling at a constant though? Since the acceleration is 0.
Huh?
Like it would be traveling like at that.
Acceleration equal to 0 means that that velocity, it's traveling left at a constant velocity. No, I didn't know. I didn't know the acceleration 0 there.
Because you saw the.
Oh yeah, you did. So you know at, yeah, I did. Sorry. So at that time, you're at a constant velocity. Very good. Total distance, quickly. Part C, you had to take your velocity equation. I'm going to erase this. Take my velocity equation. Here we go. Velocity, set it equal to what? 0. So I'm going to have to take 2e to the negative t minus 2t e to the negative t and set it equal to 0. This is where factoring you have to do it. So I'm going to take out a 2e to the negative t. The 2 is really irrelevant. We're going to have 1 minus what? Come on, help me. 1 minus what? 1 minus what?
T.
T equals 0. Is everybody okay with that? Now, this over here, that's not a 2. That's supposed to be a t.
What about cancel off?
So 2e to the negative t, okay? The 2 cancels off. E to the negative t, we set it equal to 0, and we know we can just do what with that? Throw those out. So what's the only t value? 1. Now, you do your sign analysis. Pay attention to this. T was greater than or equal to 0, so we don't need to start it at negative infinity. We're just going to go 0 to 1 and 1 to what? Infinity. We're going to see if there's a change in direction, because that's what you need to do with total distance. You with me, everybody? Don't die on me.
Would you go to 5 for this one, 7 to 5?
Oh, 1 to 5, yep. Just do 1 to infinity, though, because you know it's only one place. So sign analysis, just do 1 to infinity. Now, you only want total distance of 5. And I'm just going to do the sign analysis up to infinity. All right. Let's try 2. Plug in 2 here. When we plug in 2, first of all, this is an L curve. What's an L curve? Always positive or negative? Yeah, talk to me, guys. L curve, positive or negative? Positive. So this, no matter what, is always going to be what? Unless I would have had a negative 2 in front of it. Then it would have been an upside down L curve, and it would have always been negative. So this right here is always what? Positive. So what matters is this part. In fact, this part, you can just ditch it. You can just mentally just say, it doesn't matter because it's always positive. So if I put a 2 in here, what are you going to get? Negative. If I put a 1/2 in there, what are you going to get? Positive. So it does change direction at 1. Correct? So if I want to do total distance, it's going to be x of 0 minus x of 1. They use x instead of s. Plus x of 1 minus x of 5. Good? Position at 0 minus the position at 1, because you got to take into account change of direction. Because remember, the particle's going this. It's somewhere at 0 seconds. There's t equals 0. I don't know where it's at. This is in question. I don't know where it's at. But I know it goes to the right up to 1 second. And then it goes to the left and stops at 5 seconds. So if I don't take the absolute value, I got to take that displacement, absolute value of it. That'll be a positive displacement. But this one's going to be a negative displacement. And if I'm not careful, it's going to cancel this out. So that's why I need the absolute value. Does that make sense? What is x of 0? Looks like 0. Minus what's x of 1? 2 e to the negative 1, right? Plus 2e to the negative 1, I imagine you used the calculator. Minus x of 5 would be 10e to the negative 5. And I imagine you just did the calculator and did absolute values. What do you get?
I have 1.405.
1.405 sound right?
We have 1.403.
I got 0.47.
Let's go 0.405, 0.403, 0.407. Might round it. Then you can shoot. That worked. That right there. If you take, listen, how many of you took into account the change of direction? The 1. You get 1 point for that. You also get a point for showing the displacement. Okay? And then a point for the answer.
What if we have the wrong change?
But then you have to take
Yeah.
Huh?
We use 3 instead of 1.
one. Yeah, we used to.
Oh, I see.